See the trick and concept to integrate, let's say, a to b mod of sine x dx, mod of a to b cos x dx, and mod of a to b mod of sine x plus minus cos x dx. So there is a one trick. If there is, let's say, n1 is integer pi, n2 pi mod of sine x dx can be written as n2 minus n1 into 2. Mind it, here n1 and n2 are integers. Similarly, n1 pi to n2 pi mod of cos x dx is n2 minus n1 into 2, same, and so these both are same. Okay, either you are integrating mod of sin x or mod of cos x from n1 pi to n2 pi. We have n2 minus n1 2. Okay, now if we have, let's say, n1 pi to n2 pi mod of sin x plus minus cos x dx, that is given by n2 minus n1 into root 2 into 2. So that is there's we multiply, there's extra term called root 2. Okay, so let's say we have a 0 to pi, let's say 0 to 2 pi mod of sine x dx. Okay, 2 minus 0, that is 2 minus 0 pi. So this pi is something represent 2, so that means 2 into 2, that is equal to 4. Let's take one more example. Suppose say pi to 6 pi mod of sine x dx. So that means 6 minus 1 is 5 into 2. The answer is 10. Similarly, let's say 0 to 23 pi mod of sine x plus cos x dx, that is 23 into root 2 into 2. Okay, that is 2 3 are 6, 246 into root 2. That is the answer. One more thing, mind it, if we are something integrating, let's say 6 to 8 mod of sine x dx, then we can't write that 8 minus 6 into 2. Okay, this is wrong. It should be something multiple of pi. It should be integral multiple of pi. Integral multiple of pi. But same here, this should be integral multiple of pi. We are not expecting integers, so they should be integral multiple of pi. We can say this n1 n2 are the integers and they are integral multiple of pi. Here just a 6 and 8, they are integers but not the multiple of pi. So that's why the value is not 8 minus 6 into 2. Okay, let's take one more example. If let's say minus pi to 5 pi mod of sin x plus mod of cos x dx. So it is just as we can separate it, minus pi to 5 pi mod of sin x dx plus minus pi to 5 pi mod of cos x dx, and this answer will be, this will be 5 minus 1 6 into 2, and this is 5 minus 1 6 into 2. So the answer is 24. Let's take one more example. Let's say minus pi to 5 pi mod of sin x minus cos x dx. Okay, so we already discussed that either it's a plus or minus, we'll multiply root 2 into 2. So that becomes 5 minus 6 into root 2 into 2, that is 12 into root 2. Okay, and the same question, if I say minus pi to 5 pi mod of sin x minus mod of cos x dx. Okay, mind it, their mod is here, the mod is inside, mod is outside, here the mod is separated, the sin x and cos x. So that is two function. So that means one part is, we can directly write the answer now. This will give 5 minus 1 6 into 2, and this is minus, this is again 5 minus 6 into 2. So the answer will be 0. Okay. So let's see one more concept. n1 pi to n2 pi mod of a sin x dx. Obviously here a is, if a is any constant, so we can take a outside. So obviously this is a simple property of a modulus. See, if we know that any constant, let's say a into x is mod a mod x is equal to a mod x, if a is any constant. So if any constant value, we can use this property of a modulus. So we can write this a is outside, and n1 pi to n2 pi mod of sin x dx, and they are nothing but a times n2 minus n1 into 2. Okay. Similarly, we can write the n1 pi n2 pi mod of a cos x dx is equal to a into n2 minus n1 into 2. And this is important. So if I say that n1 pi n2 pi mod of a sin x plus minus a b cos x dx, that is n2 minus n1 into a square plus b square root into 2. Okay, or let's write like this. It's a square plus b square root into n2 minus n1 into 2. That is the answer. So it's similar to that. Other cases we have a square plus b square n2 minus n1 pi, and in all cases, mind it, n1 and n2 should be a integer. Okay, let's take one example. Minus pi to 5 pi mod of 4 cos x minus 2 sin x dx. So that is 4 minus pi to 5 pi mod of cos x dx minus 2 minus pi to 5 pi mod of sin x dx. Now we know that this is 4 and this is 5 minus 1 6 into 2 minus again 2 5 minus 1 6 into 2. Okay, so the answer is 6 to the 12 to the 24. That is the answer. Okay, let's take one more example. Let's take the minus pi to 5 pi, the same, I am doing the same problem like this. Let's say 4 cos x minus 2 sin x. So that is what 4 4 is 16 plus 2 2 is 4 root, and 5 minus 1, that is 6 into 2. Okay, so 4 6 26 12 12 24 root 5. That is the answer. So let's see the proof why we are getting this one. So let's quickly see the proof why. So okay, if we want, let's take one more example. Let's say pi to 5 pi mod of 4 cos x minus 2 sin x dx. This is same as 16 plus 4 root 5 minus 1, that is 4 into 2. No? So we have to see this is 5 of minus 1, that is 6. Whereas in this case, this is 5 minus 1, that is equal to 4. So that becomes 4 to the 8 and 8, 16 root 5. Okay. So let's quickly see the proof why we are getting this answer. See, we know that first of all, we should know that mod of sin x, mod of cos x, mod of sin x plus minus cos x is a periodic function with period pi. Second thing is we should know that from 0 to pi mod of sin x, since their period is pi, for one period that is the value 2. So this is something a sine have a one period, this value is 2. Similarly 0 to pi mod of cos x dx is also 2. So if you integrate from one period, so if you want to integrate, you can see that. So this is pi by 2, this is pi, this is the graph of, so this value is 1 and this value is also 1. So basically if we divide this part, so half of the value is 1 and this value is also 1. So that's why 1 1. Here also this 1 and 1. So the mod of cos x has 0 to pi has a value 1. By the way, the graph of mod of sin x will be something like this. Okay, they are periodic function. This is the graph of mod of sin x. Similarly, the mod of cos x will be something like this. They are periodic function x and y. So this is pi by 2, this is pi, this is 3 pi by 2. So this is period is pi. So if you want to integrate from 0 to pi, this area is 2. Here also this area is 2. Okay. And the third thing is also, if we want to integrate from 0 to pi mod of sin x plus minus cos x dx, their area is root 2 into 2. Okay, root 2 times 2 into root. So you should know, first of all, you should know that periodic function with period pi, and for one period, 0 to pi is one period, their area is 2. Their value of integral is 2. Okay, for 2 root 2. Now, next thing we should know that if any periodic function, so let's say n1t and n2t fx dx is given by n2 minus n1 0 to t fx dx. This is the one of the property of integral periodic. This is called the periodic property of integral. Periodic property of definite integration. And here fx is a periodic function with period 2. Is a periodic function with period t. So the same concept, these three concepts. First of all, what is the first concept? That sin x cos x and sin x plus minus cos x is a periodic function with period pi, and for one period they have the value 2 for mod sin x, 2 for mod cos x, and sin x plus minus cos x 2 root 2. So overall we can say that using this property, n1 pi n2 pi mod of sin x dx is, since the same as we can write n2 minus n1 0 to pi mod of sin x dx. Okay, and for one period we know that the value is 2, so that means this value is nothing but n2 minus n1 into 2. And obviously mind it, this n1 n2 this valid here, also valid if n1 and n2 are integers. Okay, so this periodic property of definition is valid if n2 and n1 is integers. So same way we can say for the cos x also, and for the mod of sin x plus minus cos x as well. So same property, using this property we can prove this thing. Okay, now what will happen? So what will happen if suppose this is n1 not an integer, so p pi p1 pi to p2 pi mod of sin x dx, or mod of p1 pi to p2 pi mod of cos x dx, or mod of p1 pi to p2 pi mod of sin x plus minus cos x dx. Okay, so what will happen if p1 and p2 are not integers? Then how will we integrate? What is the answer? Then what is the trick? Okay, this we'll see in the next video. So next video I will try to explain you what will happen if the limits, that is p1 pi and p2 pi, here the p1 and p2 are not the integers. Okay, so please like, subscribe and share if you want that these are useful. But we can solve the problem. Let's say if p1 pi, p2 pi, general case will take a sin x plus minus b cos x dx. If p2 minus p1 is integer, if p2 minus p1 is integer, then we can write as a square plus b square as usual, p2 minus p1 into 2. This is the answer. But in previous case, the n1 and n2 are integers. Here, even though this p1 and p2 is not integers, still this formula is valid only if p2 minus p1 is integer. This is the condition. Okay, we should note down this is the condition. If p2 minus p1 is not integer, we will see in the next video how to deal. But if p2 minus p1 is integer, we can solve this problem. Similarly, same with this also. Let's say p1 pi, p2 pi mod of cos x dx is equals to p2 minus p1 into 2 only if condition is that p2 minus p1 is integer. Okay, let's quickly take one example. Let's say suppose this minus pi upon 3 to 5 pi upon 3 mod of root 3 sin x minus cos x dx. Even if I take plus also, then also the same thing is valid. So that is, and what is this 5 minus 5 by 3 minus plus 1 by 3, that is 6 by 3, that is 2. That is the integer. Okay, that is clearly an integer. Since that is an integer, we know that the formula is that root of a square plus b square p2 minus p1 into 2. So root 3 square plus 1 square, that is 4. So we know that 3 plus 1 into what is p2 minus p1 is 2. And what is that 2? So this is p2. So this is p2 minus p1. This is root of a square plus b square into 2. So we formula is root of a square plus b square p2 minus p1 into 2. So the answer is 2 to the 4 to the 8. Let's take one more example. Pi by 4, 5 pi by 4 root 3 cos x dx. So again this 5 upon 4 minus 1 by 4, that is 1. Okay, so that means this answer, obviously root 3 is we can take outside. So root 3, and what is the answer of, so this is root 3 pi by 4 to 5 pi by 4 mod of cos x dx. So that answer is root 3, and this is 1. So that is 1 and 2. This is 1 because p2 minus p1 into 2. So that is answer is 2